All right, so welcome to day 4 of QuickPass, everybody. I hope that over the weekend you got a chance to do some exercises. I know I posted some stuff out on Slack. I put out a little puzzle that I had made up real quick just to see the different approaches. Um, and it didn't require a loop at all. It was just some string methods to grab the count of all these special characters, and then you didn't even have to even reorder the numbers or use a loop or anything. You could have just put the numbers 1 through 9 in there. So if you didn't get a chance to look at it, you can go see it on Slack. Copy and paste it into your Replit or any other IDE of your choice to try it out. But it was just a neat little exercise I wanted to come up with just to help hammer in those string methods that you learned on day 1. So and then of course we went into some all the data types. We went to conditionals last week, and then we ended the week with ordered data collections. So we learned about lists and tuples. Lists are one of the most common data collections in Python or any programming language, really. You'll be using them all the time when you want to put stuff into a collection and keep the same order. And then, of course, you want to loop over them. And we did get introduced looping a little bit. We'll formally go over loops next lesson, but if you have time, just at least take a look at a preview of what loops are. It's we saw that in some of our exercises we probably needed a loop to kind of quickly go over the data and separate those some of the strings. So yeah, you can just Google Python loops and you'll find what they are. And then tomorrow Wednesday we're gonna go over them in detail and learn all about all the looping that we can do. So so any questions on last week's material? Anything didn't make sense before we dive into the next lesson today? Looks like Juan posted the attendance form, so you get a chance to go into the chat here in Zoom and go ahead and click that and answer the questions. Y'all can do that too. But if there are no questions, I guess I have a question for everybody else. Who all is eyeballing trying to get into this next cohort?
I know I am for
You are?
the weekend and the weeknight and weekends. The weekend class?
Oh, the evening and weekends?
Yes, evening and weekends.
Okay.
Yeah, same here.
I'm hoping to get into the full time.
Okay. Yeah, I mean, I know I've had several students in my previous cohorts are like, yeah, well, I'm probably not going to get it this time, but I'll do it from another time. And again, when you pass QuickPass, you don't have to go into the exact next cohort. You can wait. If you something comes up and you just can't go, or if you just don't feel like you're ready, you can always sit one out and study up on your own, do the more of the intro work. So that's always open to you. Just know that the community is just really awesome too. When you can post questions in the general chat and you can ask questions. I found it just to be, it's just really awesome. Anybody's willing to help out. If you post a question, whether it be in general channel, learning about, benefits for veterans. And then there's other Slack channels as well. We have Operation Code, and then a lot of on Slack, a lot of cities have their own like tech communities as well. You can find their channels and dive in and look at available jobs. And we have, even in the Platoon chat, we have some job opportunities that pop up every now and then. So we're always looking out for each other, trying to find opportunities and assist where we're needed. And I know they've posted some I just can't think of the name, but like the coding events that we have I can't think of the name of the term right now, but like hackathons. Sometimes they'll post those, and Platoon will put teams together. I did one after Lima. We got together and did a hackathon, and it was fun. It was a lot of work over the weekend. We were trying to build a solution out for it was an Illinois veterans group. They were trying to update their stack, and so they were coming with suggestions how to do that with different technologies. We didn't get close to winning, but it was still fun. So
question: how often do you do the part-time and weekends? Is it twice a year or once a year?
I believe it's twice a year. I'm not really too versed on the schedule. I can go look it up, but I think we have 3 or 4 full-time cohorts a year. 3. This is my third QuickPass, and I started around the holidays last year. So, and I'm doing another one around the holidays this year. So I guess 4. 4 a year, and then I think 2 evening weekend classes a year because they're a little longer. And then the DevOps, I'm not familiar with that one. I haven't looked at their schedule, but I know they started one at the same time, roughly around Whiskey Platoon. So,
How much of AI are we going to be? Are we going to learn any type of AI or machine learning?
yes, yeah, you'll be introduced to machine learning concepts. In fact, that's curriculum they just really kind of got going. You'll learn about PyTorch, which is one of the libraries to process machine learning models. It's pretty awesome, actually. So you'll get to go in, like, train your own like mini model and do some things. I'm not really too well versed on it. I did a little bit of, we were turning machine learning models into like APIs, but I never did any actual coding of machine learning models. I was just grabbing the code, trying to tinker with it and look at how it worked just so I can get it running. But I didn't really actually make my own. But it can get quite complicated pretty quickly. So
Does Code Platoon currently offer an AI bootcamp?
No, it's just part of the full stack. So it's like a lesson inside of the full stack, but there is no like AI focused boot camp. So, all right, let me go ahead and share my screen. Be desktop to share. Can everybody see my screen?
Yep.
All right, sounds good. All right. Well, today we're going to go over Python unordered data structures and their built-in methods. So again, last week we talked about ordered data structures and their methods, and we learned that lists really have most of the methods. We learned that tuples, because they're immutable, a lot of those methods that will change a list in place wouldn't work on a tuple because you can't change a tuple in place. Today we're going to learn about these about dictionaries and sets, and they are fundamental data structures, and they do have unique purposes. And we're going to spend most of our time in dictionaries because they are the more common of the data structures. There is a place for sets, and we use them. We have some ways to use them, but again, you'll see dictionaries most of the time, and they the methods and just the processes with them you'll need to know. This is very, very fundamental because they tie into a lot of other concepts, and the way you think about them and how they work can be, when you're first getting started, can be a bit counterintuitive. So it will challenge the way you're thinking a bit about data storage, but they are very useful. So we are going to start with sets because it is a smaller section of this lesson, and then we'll go over how we can use them, and and I can even give you some examples of how I use some on this class. So yeah, it's pretty cool. And then we'll move into dictionaries and then go over all the dictionary methods and the ways we can manipulate data with them. And then this is going to tie right into um, every lesson here we're going through is going to build upon other lessons, and we're going to go to this culmination where we're going to be doing these mini projects. We're going to go back and use all the methods we've learned. For day 8, we're doing a Powerball generator. We're going to use every single tool we've learned in this course in that one project. When it comes to like using dictionaries and lists and strings and functions, lots of functions. So it'll be good. It's a good culmination. It kind of gives you appreciation of why we want to teach these fundamentals at this level, so you'll be ready to go when you go into Code Platoon. So Wayne Silver, I don't know. I don't know if you need any kind of link to, do you have Slack? I mean, I talked to you on it. Are you not on Slack right now? Um, oh yeah, Slack shouldn't make you pay for anything. So, you may want to check the link that you had before, but I mean, right now we're using Zoom for everything, so you wouldn't even need to use Slack right now. So let's get into sets here. So sets are mutable, unordered collections of unique elements. And what that means is they're not considered sequences because they're unordered. They are really like hash tables, and they don't support indexing or slicing. And the way you can think of like sets versus like a list is like a pillbox, right? So you go into your grandma or granddad's house when you were a kid, and you saw they had their morning, like at least my grandparents did, they had this morning like vitamin and pill routine. They had this big thing that had Monday through Sunday through Monday uh box, and they would open it up and pull each thing out every day, right? And so you had, that was like a list, almost like an order collection of those pills. And then a set could be considered like, all the unique pills into one container that's not organized by day. And that's how you have to think about these data structures too. So the you have the ordered data structure like list, and then the sets and dictionaries are unordered. So you're gonna have to figure out a way to see the data or access it, and we'll explain how to do that here. So because they can't sets can't support indexing or slicing, they do support mathematical operations. And so in this, I have some examples down a little further that that has like the Venn diagrams that show like the intersecting circles, and they kind of show how you can grab data between two sets using different methods. But sets also support, they're mainly used for membership testing and deduplication. And so with that, let's get into how we can just create a set. So you saw how we could create an empty list with the list method. So we had the word list with the open and close parentheses. But you could also instantiate it with the curly braces, or not the curly braces, the square braces for a list. With sets, you can only instantiate an empty set with the built-in method, because let me open my screen here. Is that better? Sorry, someone asked if I can blow my screen a little more. All right. All right, there we go. Awesome. So you can only instantiate a set with the set method, because if you use curly braces, that will actually instantiate a dictionary, because dictionary also uses the same braces. So Python will interpret that as empty dictionary. So here I have my set, and I'm using the set method to initiate an empty one. I run that and I get back a set. However, if you do put in data into a set initially when you're setting it, then it will be a set, because there's a distinct difference in how this data is being put into these curly braces in this example. So this ends up actually being a set, and I can prove that by doing type my set, and if I run that, I get back a set. One of the most useful and unique properties of sets is they automatically do duplicate values, and this also illustrates why sets need to be considered unordered data collections. So the set elements must be unique, so all the duplicate values are dropped if they exist more than once upon creation. So here we can take a look at my set, and I put a bunch of stuff in there, right? So I have a mix of letters and numbers, and if you notice, I have some of the same numbers in here. So I have the one appears like 6-7 times, right? But if I run that and then call my set, I only see one of them, and it's only the unique values that get shown up in a set. And so you have to ask yourself, it looks a lot like a list, and it looks like I can iterate over it, and you can. But the problem is, when you're looking at this, which one is this? From which location in the set did this one show up? And you don't really know. So in that case, you have to consider that this is an unordered collection. It's just a unique collection of values uh, in this set. Any questions on just the basic set construction and attributes for now? Art asked, would print like printing the set, or actually wrapping that with a print method? Is that what you're asking? Like doing that? Oh, no. So yeah, the type. So what I was doing now is I was just basically showing you that, my set was an actual set. If you remember, you run the type method on a piece of data. Let's say you have a variable that already exists. Maybe it was formed in another part of your code, and you want to know what type of data it is. You can run the type method to see that, to see the type, because it will just show you at the bottom. So if I ran again type my set, again, this is a Python included method just to show you what kind of data you're working with. In this case, it shows it's set. So it's a data structure. I'm going to go ahead and mute you, Michael.
I was about to ask a question.
Oh,
Sorry.
okay. Sorry.
I was trying to figure out how to word it. Okay, so just typing my underscore set and then running it will print it, but also you can print my set and then it'll
Right.
print it.
So in Jupyter Notebooks, if you just basically call a variable at the very end, it's only the last one in a script, it'll return it at the bottom as output. Printing it is different than doing this. So if I had another set, so let's say my second set. equals, and I'll do,
So it'll only call the last one in the series, not both of them.
right. So you won't be able to see my set using this, doing it this way. I mean, it won't cause a problem, but basically just this interpreter will give you back if you call a variable at the very bottom, just the last one in that script will just show up in the output.
Gotcha. Thank you.
Yeah. Got a question here. So if you used the parentheses instead of the curly braces, you would still have duplicates. Yes. So in that case, down here, if I were to use parentheses, then what data type would it be if I use parentheses versus the curly braces?
String.
Nope. Be a tuple.
Hmm.
And it's not really that, it's one of the things that you have to realize with tuples, it's not necessarily the parentheses that tell you it's a tuple. It's actually the commas in between the data that will create a tuple. But you'll see them traditionally wrapped with the parentheses, and that's usually how you'll see or instantiate a tuple. So just keep that in mind. I mean, it's good. It's general practice to have the open and close parentheses around a tuple, but you don't have to. Just the presence of the comma and the values will give you a tuple.
And it's a tuple because it's a combination of I don't know, integers and strings and
It's a collection. Yeah, if you use the parentheses, then you'll get a tuple, which is an ordered data structure. And it won't get rid of the duplicates. So let me do this instead, actually. Let's do my tuple. And we'll change it here. And then we'll print my set. And then print my tuple. There we go. Let me run that. And so you can see the difference here. So that's a really good question, Jason. So so I actually used a set whenever I was sending, as you guys were all registering for QuickPass, we have a CRM system that tracks incoming students, and we get emails and stuff like that, and I can use the system to extract a report. And so as QuickPass is filling up, we started with like 10 people and 20 people. I think the first email that I sent out with a Slack link, there were about 30 something people in my initial email. And so basically every day leading up to the first day of class, I would run my HubSpot report. And then I just wrote a Python script to take the CSV and just give me the emails in a list. And then I would just in my script, I would just take that list, and then I would I would combine them together and find I use a set to extract the unique emails out that weren't in the other report. So to know the differences. So instead of scrolling through and trying to find each name with my eyes, it was just faster to just put both those outputs into a script, and then we read them and then extract out the differences. And then you'll see what I mean when I'll show you the command I use when we go down to our set and methods, because that's what we're going to go into next. So I cast both the email lists into a set, and then I grab the unique ones, the differences from one to the other. So yep, and then Rich put out a good message about sets. So yeah, in real world, I used a set method to get unique emails, so I can send out just those versus resending out email to everybody. I was just sending them out to the new students and sending the Slack link and stuff like that. So even though we already had an automated email sending out messages with all the links as well. So I just want to make sure everybody was good to go. Yep, yeah, it can. It can help remove clutter and duplicates, really, is what you want to use for. So so there are differences between sets and lists when it comes to adding and removing elements. So with the set, we use the add method. And so if you remember, I have my set up here. And then if I want to add another item to the set, I can just put my set dot add 500, and then you can see the 500 is thrown into the set. The remove method, again, when you're typing these out, your IDE is going to be smart enough to know if you put a dot after your variable, then it will give you all of the methods that are available to your data type. So you wouldn't even have to run the type method on this set if you didn't know what it was, even though the name says my set. But if you do a dot, you'll see a lot of IDs will give you a pop-up with the available methods to that data type. So I know there's a set because of some of these methods, like difference, for example, or intersection, and then you have union. Those are all methods for a set. So I would know just looking at this, oh, that's a set. If I didn't already have the name, which is pretty obvious. So that's a way to tell if you have a certain data type, is using those methods. And then you do the dot add, right? So dot add, and then 500, and then you have remove. So I can run that, and 500 is now removed. So those are two basic methods to add and remove items from a set. The pop command removes and returns an arbitrary item from the set. You can't specify an index because sets don't have indexes. They are unordered data collections. So in this case, I'm going to run it, and I popped out the Y. So if you look here, I print the item that I had just, when what the pop does, it removes and returns that item, so I can assign it to a variable. So when I just popped the item, and then I printed it here. So any questions on those methods?
Why would you want to return a random item from the set?
That's a good question. I've never used it in practice myself, in my day-to-day job. But I will think of one, or I'll actually Google that question. That's a
Unless
good one.
Is it random every time?
Let's see. 2, 3. So I pulled the Y first. Now it's kind of going in order.
So if you use that with a loop, and you could use it almost like a random number generator, like where it pulls from a hat, or like
I would
not so much.
say no. There are libraries you want to use for random, like pseudo random number generators. You wouldn't want to use this. I've noticed that there's still like when this is still in IDE, like there's still some order maintained. I think there's something going on behind the scenes with Python with that. And I'm going to go ahead and reset this so it's back to the way it was. But let me see if it when I run it again. Yeah, I pulled out the Y again.
Hmm.
Just element. Sorry, that's just short for element. Also, Wayne, if you want to, like, so I have a TA here. His name is Rich. If you put your questions into the like everyone field, just so everyone can see it, so he can see it as well, that'd be useful. I do try and answer questions in class, but he's also here to help answer questions if I'm lecturing. So you'll see it because there's like you can see a little pull down, and you can just do everyone in the meeting or a certain person when you're chatting. Sweet. Yeah, Lever, you said, suppose you had collections of numbers, maybe they represent some special dice that can never roll the same number twice. Each time you roll the dice, it could pop some random value. Yeah. And when I've played around like making because I think it was actually one of my code platoon exercises where we had to like make a dice object, and we use the random library to make it roll random numbers. Yeah, and in fact, Michael, we're gonna be using the random library in our lottery example. So we won't be using sets and like popping things. We'll be using a different method to pull out like a random number. So these next methods I'm going to talk about are really more, these are how I've always used sets in code. So these mathematical operations are pretty powerful. And you've seen these Venn diagrams in school in math class, right? And you have the two collections. They could be anything, right? This could be like items that you eat for breakfast, and then these can be items that you eat for dinner, right? And you have like cereal and pizza, but then you have like lasagna in the dinner, and then maybe like yogurt, like fruit and yogurt or something over here in breakfast. So things that you could eat for dinner could be in that middle, and that it changes for everybody, right? So we have a bunch of them, and these all tie right into the set methods that we have, and the graphical representation. So the first one we have is the intersection. So the intersection method returns elements that appear in both set A and B. So there it's just, and that's a pretty good, it's an apt name for it, right? The intersection of the two data sets. You just want to see what they share in common with nothing else. If you want to make your selection broader, you can use union, which just mashes together two data sets into one big result. So it returns elements in either set A or set B. And so including the ones that they share. Of course, when you do that, it'll only be one value from that. So if set A and set B both share a 3, for example, you'll just get 1 3 back in that union with all the other values they both provide. But yeah, that's the usefulness of the union. The difference, there's 2 of them. There's left set and right set difference, and really it's just flopping your variables or your 2 data set names on either side of the method. So in this case, the left set difference returns elements from set A that are not in set B. So anything that's in set B that's also in set A is not included, and everything from set B is also not included. So it's only unique items from A. And then the right set difference just flop the variables, and then you get only unique items from the right side of the difference. No, I think you can only compare two sets. So you can't compare more than two sets. I've never gotten that question before. That's a good one. But I think you can only use these methods on two sets. And then you have the symmetric difference, which will return elements in set A or set B, but not both. So it's the exact opposite of intersection. And so let me see. I think I have my other set. Did I define it yet? I may not have defined it. Let me go ahead and define my other set real quick. Let me just add it right here. I thought I did define it. Maybe I didn't. Okay. All right. I think I have a good 3, 7, 1. Y is in there. Okay. Oh, I think I popped out Y, didn't I? Let me add a B in there. There we go. All right. My other set. And I can run that. So now I have my other set. And then I can run the union. So the union of my set to my other set. And this is what I get back. So, like the 10 is unique to my other set, but the 1 is unique to my set. And so it's just putting everything together. So the union is putting everything together. And then here you have my set difference. So again, the difference when you're looking at this, I want to pull stuff from my set. And if it's in my other set, I don't want it. I just want something unique to only my set. So my set, again, contained the A in it. Let me see. I don't think, did I put the A in my other one? No, I put the B in my other set. That's why it shows up.
So union would, if you have two lists, two
Sets.
groups of sets, it would just pull the uniques from each into one list, one set.
So yeah, so remember you're dealing with sets. So if you have one set of data, if you look at this graphic, I know it's kind of small, but it's basically when you're using a union, you're pulling everything from both sets. So now if they both share the same value, for example, if my set and my other set contained a 500, it would only still give you just one of the 500s.
So it
So
consolidates the two sets, the uniques from each set together.
yep, and it gives you it returns another set.
So if you had like 3 ones in each set, it would just put 1 1.
Correct. Yeah. A set will always be just one of the values. You don't know where it came from. You don't know which one this exact one came from. And really you don't have to worry about that. It's just you have a 1 in somewhere in both of the sets. So and that's what this really kind of helps explain it by looking at how the graphic works. It ties right to how it's pulling data from. With this left set difference, only pulling items from this one only, and not the ones they share. Here's the symmetric difference. So my set and my other set, I can run that. And so now these are the ones that are in either, but not both. So symmetric difference, it pulls data from the blue areas, which is from my set and my other set, but if they share it, it will not be included. So for example, the 500 I had removed from my set before, so it wasn't in there. And so it gets included because it is in only one of them. So that's what symmetric difference is. Here, I'm going to redefine my other set to this, and then I can print it, and then I'll show you intersection here. So I'm printing my set. So this is what my set is. And then I'm defining another new my other set. So I'm redefining my other set. I'm going to print it. So that's my other set right here. And then I'm printing the intersection. And so the intersection is only what is contained in both. And you have 3, because 3 is here and here. You have 4. 4 is there and there. And A. A is there and there. The rest of them are unique to either one. And so while this is cool and all, like, cool, you're showing me letters and numbers, but what does that mean? Well, here's an example. I mean, you know, I know not everybody here has been in the military, and if some of you can be a spouse, but you know, the annual training lists, we've all been subject to those. And when you get flagged as yellow or red on a cell sheet, and you have to finish your annual training even before it's due, we could, this is a good script to kind of do that. So we have our employees, right? And I try to make this set a little longer, right? So there, it's a, where you can't really quickly find, names, and then you have who's completed the training. And so we have a whole long list or a long set of people who have completed training. So who hasn't completed training? What could we run to figure out who still needs to complete their annual training? Well, if this set is people who have completed their training, and then we have all of our employees, so these people should be in this list somewhere. And you can see like Jess is right here. So we would use the difference between the two to figure out who needs to take the annual training. And so we could run that. Oh, let me see what I did. Oh, I didn't run this. Run that first. There we go. So these are the folks that need to complete their annual training.
So you'd run the A difference to compare A to B to deduct out group B, leaving only group A, or the list of untrained.
Because the ones on the right were the ones that completed training. So, and then I don't want the ones that were in both lists, because that's really the ones from the right anyway. So just, I didn't want to include any of those. So only ones that did not complete training. It'll take a bit to, wrap your mind around the terminology and the usefulness, but that's, one of the applications to a, somewhat real world example is, finding the training. So, and that's it with sets. That's the extent of, what you'll need to know with sets. You may not even use sets in, the challenges or anything else, but you could. Again, all these tools and these data, these methods that you are learning, when you put it together, you come up with a solution, right? So like I had some folks giving me a solution to that problem I posted over the weekend, right? And they were not wrong. I mean, unless the result is wrong, if you get the result that you want and you pass the test, then your result is correct. So there's hundreds of solutions for these. And if you want to use a set, versus a list, and you can make it work, then great. You learn something and you're able to practice with a data structure that a lot of people, don't work with. I mean, they do. I mean, we all work with sets when we're in programming, just not as much as we do with, dictionaries or lists. Those tend to be the more common data sets we see. but I'll illustrate a very, you know, a similarity between dictionaries and sets here very soon. But I think for now we can go ahead and take a break. I know it's a little early, but we're at the end of the set lesson, so I think we'll go ahead and let's just take a 13-minute break, come back at 7, and then we can start with dictionaries. We can go to the dictionary lesson. Let me go ahead and pause the recording. All right, welcome back from the break, everybody. You know, before the break, we talked about, we introduced unordered data structures, and we went over sets and their set methods. And you're going to find when we get into the next type of unordered data structure, which is dictionaries, that, you know, dictionaries and sets are very similar, and, you know, because they're, you know, the way they're constructed is the same. But dictionaries have a bit more power because of their construction. So dictionaries are a mutable, unordered collection of key value pairs. And then unlike the sequences we saw, like lists and tuples, those are indexed. Dictionaries are accessible by their keys. So they have a key and a value. And you can think of like a dictionary where if you want to get the value, you have to use the key to get to the value. And dictionaries share many properties with sets. Both sets and dictionaries are unordered. Both sets and dictionaries are wrapped in curly braces. So that's what I was talking about when you use the empty curly braces on a variable name. If you did that, it will default to a dictionary. So if you want to instantiate an empty set, you would have to use the set method to instantiate that. Sets must have unique entries, and dictionaries must have unique keys. And you can think of sets almost like just the keys of dictionaries without the values attached. That's really kind of how a set behaves. So and you think about the keys of a dictionary, and we'll look at the structure of a dictionary here in a minute. The keys have to be an immutable data type. So immutable data types could be numbers. It could be a string, because we know strings are immutable. You can't change them. It could be a tuple. Tuples are also immutable. So we have to have immutable data type for the key, but the value can be any data type. So a value in a dictionary could be another dictionary. It could be a list. It could be, you know, a string. It could be all sorts of stuff. But when you look at like when you look at Python dictionaries, think about it as like a driver's license. And you can even go a little further and you think about, you know, several driver's license, but, you know, for example, your driver's license, though, you have a bunch of key value pairs on your, you have a bunch of key value pairs on your driver's license. If you think about it, you have a license number. There's only one license number category in your driver's license, and that's where your license number is, right? Hopefully that will be unique to you only and no one else in the state. But some of them will not be just unique as far as values. But there's only one date of birth field. There's no other date of birth field on a license, and your date of birth will go there. But you may share a date of birth with somebody else. But for your license, you have the date of birth field, which is a unique field there's no other date of birth field. And then you have your date of birth as the value. And so how do you access your date of birth, or how do I access the address of this person's license? I go look for the address field, and then I look at what the address is. I use the key to find the value. How do I find her weight? I go to the weight field and then look at the value. So the driver's license is a great example of a common object in our lives that has key value pairs. Any questions on that? Yep. And Tabrick put in example friends here. So he has Alice and then the number, and then Bob. If you notice, the string Alice is the key and the value is the number. So let's go ahead and take a look at how we create a dictionary. So like sets, dictionaries use curly braces, but the pair of empty curly braces will get interpreted as a dictionary. So in this case, we can do that. We have an empty dictionary here. If we ran that and we ran that here, we have an empty dictionary. And of course, we can always run the type method around it. And we will see that. So here, it's a dictionary. We run the type method. The biggest difference between a set and a dictionary is the presence of a colon. So when you look inside the curly braces, if you're your first time looking at these data sets and you see the curly braces, hey, Aaron said that I have curly braces, that's a set or dictionary, and then I look for a colon. You see a colon in there, then you know you have a dictionary, and your key is separated from your value by that colon. So to the left is the key, and to the right is the value. And remember, the keys must be unique. So you can only have one hello key in this dictionary. You can only have one world key. You can only have one thank you key in this example. But you can have commas separating other key value pairs in the same dictionary. So if I ran that, this is what I get back now. Now my variable English-French dictionary is that structure. You have your dictionary, you have your keys, hello, world, and thank you, and then you have your values, bonjour, mon, and merci. Any questions on the structure of a dictionary?
Does the key have to be a string? It can be like a number too, right? Or
Yep. Yeah. So
or
the key
couple
can
or
be
Mhm.
yeah, the key can be any immutable data type. So we know strings are immutable. We've previously we've tried to change a character in a string in place, and you can't. It won't let you because it's immutable. Same with a tuple. You can't do that. So a tuple could also be a key in a dictionary. I do have a good example of that. Working in the geospatial world, we work a lot with coordinates, and coordinate pairs can be a great key if you're looking at finding like how often a certain one occurs or something else. You can have it as a key, and I can show you an example of that. So, but we're going to kind of go with this theme of the English-French dictionary because this one here has like the English words as the keys and the French words as the values. And like I said before, you can access the dictionary's values using its keys. So, like with Python lists and tuples, we have the square bracket in the syntax, but index is not used. So when you think about how we're going to access the word bonjour, here we have our English-French dictionary, we have the open brackets, and we put our key in here to access it. So we know in our dictionary, hello is the key, and we want to get the value. That's how we access the value. We use the key to access the value. Dictionaries are mutable, so you can also add and reassign values to a key. So I could change that dictionary value if I want. I could change to whatever I want by just using the key and then using my assignment operator. So if you take a look here at my table, I have the first one is accessing a value. So I just want to see what it is. That's exactly what I do here in this field. I want to access the item and see it. Now, if I did it this way, and then I use the key, and then I use the assignment operator, this is what will become the value. And I can actually do that here by saying And I can totally mess up this dictionary by saying, now I can just say hello equals chicken. And if I run that, now if I went and looked at my English French dictionary, hello now equals chicken, which is not what we want, of course. So I can just rerun this cell back up here. You see that number pops up to 10. Now if I got rid of that again, now it's back. I reassigned it. So that's really important when you're you'll see how we use dictionaries. Then we start using loops. You'll want to assign things in dictionaries a certain way. You'll use this syntax right here. So when you want to assign when you want to assign a value to a dictionary to a certain key, that's how you would do it. No, James. Also, James, you sent me a direct message. So if you want to share that with the class, but he said, so assigning definitions, you use the curly braces, but for running it for definition, use the square brackets. Well, no, so I'm gonna assign a new key value pair right now. And if you take a look here, I have my English French dictionary, and I'm gonna use these square brackets. I'm gonna use a new key that doesn't exist in the dictionary. So I'm making a new key, and I'll also make what it equals here. So I have my English French dictionary at the key of goodbye is au revoir, and I go ahead and run that. And now my dictionary from before, I had these 3 items right here. And now I added a new one by putting a new key in and a new value. And so now I have 4 items in my dictionary. So one, there are no indexes in dictionaries. So you cannot access a value using any indexes. You have to use the key. Cool. And again, I've already shown you overriding an existing value. So here in this case, we have our English French dictionary, and now we have the key of hello. But now I'm going to assign it a list. So I'm making a list now. And I mean, in French, there's several ways to say hello, but here we have our 2 most common. We have our bonjour and salut. If I run that, now the key of hello has a list as the value, and then the comma separates entries. So this is one key value pair here. You have your comma, you have your next key value pair here, and comma, so on and so forth. Now, to expand a bit on what one asked about accessing the index of a value, and this is a little example here. So what am I doing here? So I'm saying English French dictionary at the key of hello, and then I'm doing something you've seen before with lists. What does this do with a list? Or not just a list, but with any collection, ordered collection. What would happen here?
It would grab the first item. So in this case would be the key.
So this,
Oh, no.
so this grabs the key where I highlighted, right? So this is the key, hello, of the English French dictionary. So if I ran that, which I did already, right? I actually ran it up here, right? So I ran that. This is what it is now, right? But remember, my value is now a list. So then I want to grab the first item of that list, which is
Bonjour.
bonjour. Yep. If I wanted to see only salut, I would just do a 1. So we're kind of combining now. We're accessing a value in a dictionary by using the key. And then because the value is a list, I need to use indexing to access a certain one. Now, what about if I did this one? What would it return?
Bonjour or salut.
I'm using now for the key of goodbye,
Oh, you said goodbye.
which is
But then
right
you
here.
put the index 0.
So I'm leaving the index 0. Let's see, we have an error, we have undefined, we have au revoir. How about A?
Because you reversed it.
So why would it come back with just the A?
You just asked
Because
for
it got the first letter from the string. The value was a string and it got the first value from the string.
Correct. So the string itself is a collection of characters. And so the first item in this string is the A. So remember, I'm using this to access the entire word, and then I'm using this to get a certain item in that collection. In this case, it's a word, it's a string, so I can then access the characters in that string with that. So I go back to this, because the key of hello gets you back a value of a list. The first item is the entire word. What if I wanted to access this B? What would I have to do?
Another bracket with a 0.
What's that?
We would put another bracket next to it and then would put 0 inside the bracket.
So like that?
I think so.
Yep. Very good.
Could you do it the same way like you did in the last example?
What do you mean?
Like instead of hello, what you put bonjour then 0?
Oh, like here?
Yeah.
So you want me to put like another one, or do you want me to?
No, like instead of hello, could you have put like in the example that you have for goodbye, but instead of hello, you put bonjour, then keep the index 0 just to get the first character B.
Oh, so let's just do world then, right? So
Right.
in this case, world at the index of -1. What would I get back?
W. Hold on.
E.
Oh yeah, the last one.
Yep.
I
You get the
forgot.
last letter, so it would be right there.
Gotcha.
Yep. All right. There we go. Salute. All right. We can also delete a key value pair from a dictionary using the del keyword. So just remember, when you do this, there's no confirmation and it's completely erased, so you can't go back. So, oh, Brittany asked, could you do 0:8 on which one?
Where you originally had 0.
Uh-huh.
I can't remember what else you had after that.
So in this case here, like if I want to take a slice of something, right? So for hello, it'd be a list. And so I could do, let's just change it to like goodbye. So that way we can kind of see. So goodbye. Oops. Goodbye. And then 0. I think we have 0, 1, 2, 3, 4, 5. Yeah. So run that. This is what we get back. So there's no R at the end. Because I'm taking a slice of the string. So in this case, I'm taking up to, but not including index 8. Index 8 is the R. And I'm up to, but not including 8. So I'm getting index 7 and everything before that. So Rich put in a good example, some additional visualization of like objects. We call them objects in JavaScript, call them dictionaries in Python. But a good visualization of that. Let's keep that there. All right. So with the delete keyword, there is no confirmation. So if I ran delete English French dictionary at the key of world, and then I ran it, now it's no longer there. It's just completely gone. So if I wanted to put it back in there, I'd have to go back and put in English French dictionary at the key of world equals mon. So I will not be doing that though, but that's how you would do it. Any questions on some of those accessing the keys, seeing the values? Just remember this process is a bit hard. It took me a while when I was learning about dictionaries, how you have to use the key to access the value. There's a way to see your values without using keys, but to access the values, the easiest way to do it is through the keys. So use a key to access a value, and you can do stuff. So and that's what makes them unordered. It doesn't matter what order the keys are in because the keys are unique. So your data will still be, it's unstructured, but it's still organized because it's organized by keys. So we have a keys and values methods to see just what the keys and values of a dictionary are. And these methods return things that look like lists, but they aren't lists. So they're special Python objects that you can still view and iterate over, but they are not lists. You'd have to cast them to a list if you want to actually save them as a list. And you'll see what I mean here. If I run English French Dictionary .keys, I get back this weird object, and see it looks like a list, but it's wrapped by this dictionary keys method. Just know that this itself is not a list, but I could cast it to a list if I wanted to. So conversely, if I want to see just the values, this is the values. So I can see the values of a dictionary, and I can iterate over this to find them and do things with them if I wanted to. Excuse me. But these are not lists themselves. You'd have to cast it. And we'll explain why. We'll see why later on in other lessons. But in this case here, just know you can use the .keys method to see the keys. You can use the .values method to see the values, or all together we can see our keys and values in a list-like object of tuples with the items method. So in this case here, we have our English French Dictionary .items. And if I run that, now I have my items, and I have tuples, these tuples that are organized in this object. So I have these tuples that I can use to iterate over. And you'll use this a lot when you're iterating over a dictionary, because you can, even though they're unordered, you can still iterate over a dictionary, and you will iterate over dictionaries. And it's really important. This is kind of one of those like almost foot stomping moments here, where you want to learn how to use this to iterate over a dictionary. And we will go over that Wednesday with looping. We'll learn how to loop over the dictionary items and how to do that. So knowing these and how to see the keys and values of a dictionary is super, super important. You'll be using it a lot when you're coding. So Eric, so you recognize when something is a tuple when it's usually wrapped in these parentheses, and then you'll see a comma. So you have this item right here, and then you have this item right here. There's 2 items in this tuple, and there's a comma separating them. And so this is one item because it's showing a list. So this closing brackets here, that's an entire list. So you have 2 items separated by a comma and then wrapped in a parentheses. That typically tells you have a tuple. And that's exactly what this is. So here are some dictionary methods that we use. The equivalent of a tuple or a tuple in JavaScript. Does JavaScript have tuples? I thought they did. Rich is a good person for that one.
No, they don't.
Okay, so they don't have tuples.
No.
I can't remember. No, I've been in Python land for like a couple of years now. I haven't really done much. Maybe some. I did some React stuff, but yeah. So I guess I need to get back into it. Yeah, a list is an array. A dictionary is an object. Typically, you call those in JavaScript.
Yeah, they have sets, but that's a more abstract item in JavaScript.
All right. Moving on, we have our dictionary methods. So starting with the get method, you'll want to use this in Python if you're not sure of what the keys are, which you shouldn't be unsure what the keys are. But if you're just trying to grab something from a dictionary and you try to use a key that doesn't exist in a dictionary, you're going to get an error. So errors, while they're useful, right? This is useful to tell me, hey, by the way, in this dictionary, whatever you're trying to access doesn't exist. The problem with this is an error and it would break a script. So if you're looking at trying to, maybe interrogate some data that's coming in to your script and you want to use a key that may not exist in there, just straight up calling that key and trying to get a value will break a script and cause it to stop. And then you have to, go look at, see why it stopped and restart it. So, and that's okay. If you know what your keys are, you can get away with using this method. And I've done that several times. The problem with using that, though, of course, you can get this error and it stops your script. But there is a method called the .get method where you can put in a key that you're trying, and then if it's not there, you can specify a default value if it's not present to kind of, instead of break a script, just give you a value that will be okay. That's not found. So for example, I can say, and I'll just do it right here. I think further down, I do it right. I can't remember if I do or not. I have update. I do. It's way down there. Okay. But I can do it here. So run it again. English. And again, also with Visual Studio Code and most IDEs, when you start typing along like a long variable. If you notice here, I only typed in like 4 letters and it narrowed me down to what I'm looking for. If you just hit tab, it'll autocomplete for you. So just makes your typing a little faster. So I can say .get, and then I can say library. And then for default, I can say not found. So in this case, if I run this here, I'm going to get back not found. So I'm trying to like interrogate, the dictionary for this key. If it's not there, I get not found instead of it giving me a key error and breaking a script. So that's a way to get around that if a key is not present. We can also use the pop method remove an item with specific key returns value or default value if the key is not present. It's kind of the same thing as the get. So if you're trying to remove something, a certain key, but if it's not there, you can just say not found. In that case, so I just totally popped it, and there it is. If I run that now, hello is no longer in my dictionary. So the pop actually removed the item completely, and now my English French dictionary does not have it in there. Any questions on get or pop? Right. If you're removing, if you're using like pop to remove a key, yes, it will remove the value. So it's that's really what you're doing is you're removing everything from there. So if you remove a key, the value goes with it. So okay, here I kind of wrote that up here already. Get library not found. And then let's see what I'm doing here. Redefining it. So I'm going to redefine it twice. So here, run that. And now I have my English French dictionary, which has now one value in there. Okay. The dictionary pop item will remove and return an arbitrary key value pair, just like we saw with sets. You return that arbitrary value. Again, I've never used pop item before when running a script. I guess, you know, if you don't care, like if you're running a loop on a dictionary and you're wanting to pop items out for, you don't care about the order or anything, or you don't care, which you shouldn't because dictionaries are unordered anyway. You know, you could use that to, you know, iterate and pop items out or delete items as you need. You could use that method. But I've never used it really in my coding journeys. The dictionary update though I do use a lot, and so this one is where you can take another dictionary and then basically inject them into your other dictionary. So if you have a dictionary and then you want to update it with data from another one, use update and it will do that. And so I illustrate that right here. So I have this now very empty, almost empty English French dictionary, which only has one word, but two options in French. I have my new English French dictionary, which has a much more complete, it has a good variety of terms, such as, for some reason, we always want to know where the bathroom is and the library, sometimes the same time in Spanish class. So in this case, we have our new English French dictionary. If I want to update my English French dictionary with the new one, this is how I do it. I have my very empty one here, and then I use the dot update, and then this is the one that's way more complete. And if I run that, now my English French dictionary is full of information. But if you look what happened, I lost my list of terms because it got overwritten with the update because I had the same key. So in that case, it wasn't quite as complete. I would need to update that or reassign the key of hello to the list with both of the French terms for hello. So that's how you use the update method. Nope, there are no duplicates. So remember, the keys in a dictionary will always be unique. So that's how they behave like sets. You know, if you update it with another dictionary that has the same keys, the key, the values will be overwritten with whatever's coming in, but you'll maintain the same key. So, but what if I did this? What would happen? Let me go ahead and add another code block. What would I get here if I ran that?
Bonjour.
Bonjour.
I'll get a key error. It doesn't exist.
Oh, caps.
Mm,
Yep.
that's well.
So it is case sensitive. So you got to keep that in mind too. You'll find that when you'll learn pretty quickly when when you're working with bigger dictionaries, you'll want to keep your keys in the same format, right? You want to mix them. So you just want to keep that in mind. So that it is case sensitive. So in this case, it's all lowercase. Okay. Again, using the pop method, I popped out the key of hello, and now it's no longer in there. If I run the get method, hello is not there, so I came back with my default, which is not found. And then here is my English French dictionary using the pop item method. So going back up to the top here, we have our pop item method returning an arbitrary key value pair. Now for IDEs, typically it still kind of goes in some sort of order, but we have to keep in mind that dictionaries and sets are unordered data structures. There is no order. You could get something back different. I remember there's a way I can illustrate that. I just can't remember what I did before. So I'll have to go back and look at that. So but that's really dictionaries and how to access the values from keys and see the data. We're gonna do a lot more with these. And so when we get into looping, you'll see the power of having a dictionary and how you can use dictionaries to count things, to count, different things that you have in a big data set. There's some pretty cool examples of what you can do with dictionaries. Any questions on dictionaries as a whole, this whole section? Okay. We'll move on then. And we still have about 20 minutes for the break. So we have some common operations across data structures here. So we've seen these before. I kind of showed you these with lists. When we looked at the max and min, sorted, the sum. You can still use these on sets and dictionaries. So because you can still sort the keys and you'll actually get back a list sometimes when you use like sorted, for example. So in this case, we have a set here, and I just have a set of just values of letters and numbers. I want to return the max. It gives me Z16. And the reason it gets you the Z is because the letter Z has a higher ASCII code value than the other letters. So it's going to give you that as the max. Conversely, if I use min, the A is going to be the min. So A18. I'll actually pull those up real quick so y'all can see that. I want you guys to see the ASCII tables. Let me go to my other profile. There we go. I'll make it bigger. Command. Here we go. Right. So the ASCII stands for American Standard Code for Information Interchange. But if you want to take a look here, we have our character like A, for example, right here. And then the value typically is going to be this number. So you have your 65. B is 66, all the way down to Z, which is 90. And then you have the square bracket is 91. Your lowercase values are going to be even higher. So 97 through 122. So your letters have a value behind the scenes with computers. And when you're sorting letters, that's how they get sorted in alphabetical order, because they have the values. Any questions on that?
In what scenario would you use Lin collection?
What's that?
In what scenario would you ever use the Lin collection?
Oh, all the time. When you're wanting to get the length of a list, for example, because you know how long it is, you would use that. And you would use that value to determine like when you would stop a loop, or there's all sorts of stuff. Like in JavaScript, for example, there is no -1 index. So you can't use that in JavaScript. So you have to use the length of the collection to get like when your last index would be. So you would use len collection, I think it's len -1, right? If you wanted to, or the len, you would use the length -1 as the index to access the last item in the list. So yeah, but Python, you just use -1, it gives you the last item in the list. So here's, for example, right? Like, how long is my dictionary that I have?
Okay, that makes more sense. I can see how
Yes,
that could be cool.
there's 10 different unique keys in here in my dictionary. But what if my dictionary was 1,000,000 items long? Like, you can get the length. So and then sorted. Remember, sorted will actually return it'll return a copy. It will not, I mean, you can't really change a dictionary's order anyway because it's unordered, but this will give you a sorted order of keys. Correct. Length only counts the keys, not the values. That is correct. Because you're only concerned, use the keys to access the value. So you want to be concerned with how many keys you have. Because a key may access a value that has several items in there. Maybe another dictionary, or maybe a list of items as the value. So you want to, the keys are unique, immutable data types. So they're, that way they, it maintains some integrity, if you will. So. You'll use these a lot too. The min, max, sum, sorting, those methods are used quite a bit. So, but that's it. That's the introduction to unordered data types, the sets and dictionaries, and their built-in methods. I do have a few exercises down here, and again, and I can even give you guys a little preview of loops, so we can kind of see that. But let's go ahead and take a break first, and then I will actually dive a bit into loops to give you a preview, and then we'll go over it in detail tomorrow. But this right here didn't work for you?
No, I ran it and I never did quite figure out why it didn't work. Can you demonstrate it working for you in some way?
Yeah, it's right here. You know this right here? Reverse equals.
Was further up in the lesson where they started doing that.
I thought it was the only place we used reverse. There's another spot. Maybe there was.
Unless it was in lesson 3.
Well, in lesson 3, we did use reverse when we were sorting the list. But this is the same exact like process, if you will.
Okay.
I have a good one, Rob. Yeah, true. If it's not capitalized, maybe, but you typically will get an error if you run it like that. Yeah, see.
Right. It's not there.
Yeah, let's go ahead and take a break until 8, and then we can look at some of these assignments. We can go over anything you don't understand on lists. We can revisit, and actually I will go over a bit on just basic looping, just so we can use that in our exercises. So go ahead and pause the recording. All right, welcome back from the break, everybody. So again, we kind of concluded our lecture on dictionaries. There are some assignments down here that also open up in Replit. You can take a look, fork it over to your account, and try these exercises. Some are pretty good. And we can even possibly do one of these in class. But before I did want to kind of give a quick introduction loop. So, this kind of, these classes are always in, flux. Every time I go through a class, I see some things I want to change about the class. And I think in the pre-course, I'm actually changing it now, but I did want to throw a little more detail on loops in here just so you have them. I think it's in my scripting section now. Let me see. Yeah, right here. So I'm kind of writing out like looping, and I was going to write out some how to like read a loop, and then in Python, I don't want to get too in depth because there's a lot more with looping, and looping really is kind of a way to get through a ordered data structure or unordered. Just you want to iterate over it so you can do some sort of thing repeatedly. So let me go back to, I think I had it here. Yeah, blank. So and I just wanted to kind of show like really just a for loop, and you can use that to loop over a collection such as a list, right? So you have my list, and that equals, and I'll just do we will go and we'll do fruits today. Do some fruits here. So we have apple, do pear, and then we will do apple, pear, and banana. And for when we write a for loop, you can see this is kind of a key word because it shows up as red. So we can say, and then when you introduce the loop structure, you want kind of a descriptive name of whatever you're iterating over, right? So you have the list as my list, or let's say my fruits. You want descriptive name of what you're iterating over, and when you start the list, you're going to start. When you start iterating over, you're going to start with the first item in the list, and then kind of go up. And so by default, you can loop other ways, but in this case, we're gonna loop over in ascending order, starting with the 0 index. you want something descriptive when you're talking about it, and we're inside the loop, you're gonna be looking at one item at a time. And so in this case, we probably say for fruit and fruits. That's probably the best way to find that line. Or my fruits, sorry. My fruits. So in this first line, we're saying, hey, I'm going to start looping over these fruits. And every time this loop goes around and loops, every item, it's going to define fruit as whatever item it's on. So the first time it runs, fruit is going to be apple. And then whatever I do in here, like with that logic, I'm going to define here in my loop. And then when it's done, it's going to then go to the next one, which is pear. And then the next one will be banana. So fruit will be redefined every time this loop runs. And so in this case, I want to say if, so I can use my conditional statements now, right? So for fruit, my fruits, if fruit equals banana, if fruit equals banana, then I can say I can print yum. And then you know, if fruit equals pear, I mean, I don't like pears, so I can print I can print this.
Ick.
This is a
Icky.
fruit. Disgusting. Else print meh. All right, with that. So all right, so I'm doing lots of things here, right? So in this case, I'm looping over my fruits, and I'm going to do something depending on what the fruit is, right? So first time this loop reiterates, apple is going to equal fruit. And then it's going to go through this logic and say, well, if fruit equals banana, then print yum. If it's pear, then it's going to do this weird thing that I did, right? I showed you this with string methods. Otherwise, you're gonna say, nah, it's okay, right? I guess like fruit. So if I run this, the first time it runs, it's gonna be apple, right? So apple does not fit banana, and it's also not pear. So it's gonna go to this else. It's another kind of fruit. So it's, you know, okay, apple, sure. And then the next time it's a pear. And then here I'm running the first one. The first time it iterates, or the second time it iterates, it's gonna go to this if statement. Pear does not equal banana, so it's not going to go there, but this is going to satisfy it. And then it's going to print the statement, right? So this is a pear, disgusting, right? So I put fruit to show that the second time this iterates, fruit equals pear. So that's what I did there. So this is a pear, disgusting. And then the last one is banana. So fruit equals banana, print yum. So it's a way to just, you know, a loop will allow you to go over it and do something with each item in a list or a dictionary. With dictionaries, you have to do with something a little different. And I'll talk about that. I'll talk about that tomorrow. You have to kind of combine. You can combine the keys and values. So. Yeah, so James, the F is that F string. So in the first lesson, when I talk about data structures, I talk about the formatted string. It allows you to basically inject a variable right inside the string with these curly braces. It makes it a little cleaner than when we had to do it before. I think it was introduced in Python 3.6 is when F strings were introduced. It's just a way to inject a variable, and it will auto format it to a string. You don't have to worry about casting it or anything else like you used to before. So it just makes things a little easier. Yeah, sorry, not tomorrow, Wednesday. Thank you, Regina. So yeah, so not tomorrow. I'll be talking Wednesday. We will not have class tomorrow. So we'll have plenty of time for exercises, and then also we'll have time for to do the part 2 exercises. That's really what we need to be focusing on. But if you need extra practice, the exercise at the bottom of this lesson, we can go over that. So hopefully that cleared up a bit on, looping. I know you can Google looping and see it. There's plenty of examples on there. We'll go more in depth on Wednesday with looping. So yeah, so we can take a look at some of these assignments. Or does anybody have any questions on previous assignments that we've done that they're stuck on? I know some of y'all have really got into that QuickPass channel and asked questions. Hopefully, you've been happy with responses, whether it be from another student. But I do like seeing the discussions. I think that's important. When we go in here and we ask questions in the main channel. Again, I'm not always monitoring Slack, but I like to get on there when I can.
What's your hourly rate for one-on-one tutoring?
My hourly rate, I'll have to be as a we'll have to set up an agreement, also draft up a contract or something, I guess.
200 an hour.
Maybe 150, I'm not sure. But no.
Steal.
But again, asking questions in the classroom, I know some of these students in here are pretty smart, even smarter than me with Python. So I am not the most knowledgeable, but it is my profession, and I do enjoy it. So yeah, the Slack channel, it's just ask the questions, and I usually get in there pretty quickly. I do turn off alerts on my phone at certain hours, but I will get back to you. But let's take a look at one of these. Well, thank you. So my day job, I'm a software engineer for a company called NextGen. When in my introduction I talked about my history, didn't I? I don't think I did I?
You did.
Yeah, I thought I did. Yeah. So I was a weather guy in the Air Force, did weather for 21 years. Yeah, I loved it. It was awesome. In fact, there's a couple students in here who knew me in my previous life. So it's kind of cool to see some of them. But yeah, so I did weather. I was stationed mostly in the States. So I went through, I taught the schoolhouse at Keesler, the weather schoolhouse, and then I did some bomber support up at Ellsworth, and then my sunset tour, was here at Scott. I don't really count Scott as my sunset. My sunset tour was in Guam, so I was there for 4 years, and I absolutely loved it. Did some cool stuff there, and that's when I decided. I talked to my sister. I'd come back to the States every now and then for training or whatever, and I would always tie with leave since it was such a long flight back. And I was starting eyeball retirement, and like, what should I do? I have to go be an instructor at the schoolhouse at Keesler, and be a GS9 and just do that. And my sister convinced me to move into tech, and I found Code Platoon whenever I had already hit the button to retire. Yeah, I couldn't take the unit I was in anymore. And so when you're done, for sure. And I hit the button and found Code Platoon. I didn't know what I was going to do. I found Code Platoon, and it worked out. I was already teaching myself Python, and so I learned Python on my own a little bit, got into Platoon, and the rest was history. But yeah, so I work as a software engineer now for a company who does a lot of work for Air Force weather. So I'm still working with weather, but now in a coding capacity. So, but I've done work on one of their new operational programs they use, and then with some of the machine learning stuff, and doing some research for like, looking at satellite images and trying to forecast, using machine learning to forecast clouds and icing and turbulence. And then now I'm working with the Army. The Army has their own application they're using for the intel side, and we're building out an application for them. And it's been pretty cool, like putting my weather hat on and then also helping with the code. I'm not doing as much raw coding now. I'm doing more customer, like client engagement. But yeah, so I'm a staff software engineer for that company. But less in the way of software, more as a weather SME / software. So I can dive in and code if I want to, but typically I do more talking to the client. So I'm going to pull up one of these. I think this one's a good one. Let me see. Let me switch my other profile. There we go. All right. Car trip. We'll fork this one. Oh. I wonder, because I have a bunch of, I may already have, let me see if I have my other ones. Oh man. Ripples. DNA, reverse problem, camel case. I couldn't fork it over? Fine, we'll just do it this way.
Yeah, I just copied it over into code spaces.
There we go. We can just do it that way. Okay, so let's do this exercise together. This one uses dictionary, which is nice. This is exactly what we want to do. So this one here says, write a function that takes in a car object in the form of people, miles, spare tires used, and the number of miles driven as an integer. Update the car object to include the new amount of miles on the odometer. Additionally, the road is very rocky, so you need to use an additional spare tire every 1,000 miles. That's a very rocky road. Update the car object to reflect this too. Okay. That can be a bit confusing for someone who's like, really don't understand what that means here and the context of this. And so what this is, kind of how this is broken down is, here's the function they want me to write. And we know it's a function because of the DEF, the def keyword in front of it. And we have the name of the function, and then we have our parameters here. So it looks like it takes two parameters, one being car object, one being miles driven. Those are defined and used inside the function. When we pass information, when we call the function, then the car object becomes whatever we're passing in, and then the miles driven is the other thing. And so looking at this and the way this is kind of broken down, this is like just one example. And what this is doing is this is evaluating whether you got this right, whether what you wrote in this function actually did what it's supposed to do. In this case, we are calling the function right here. And inside the function, so inside these parentheses, so this, see the purple parentheses here is kind of the two parameters. The first parameter is what they call a car object, or a dictionary with some key value pairs in it. And the other one is miles driven. That's at 5,500. So miles driven is going to be an integer. And that's what it says here. Miles driven is an integer. And then the car object is in the form people, miles, spare tires used. So if people, miles, spare tires used. What is when we're looking at this, we know this is a dictionary. So what is people? And what is miles and what is spare tires used?
Keys.
They are keys, right? We know they're keys because they're on the left side of the colon. And then we have the values after that, and we have the comma separating each one. So you'll commonly see bigger dictionaries broken down like this, where you have your opening curly brace, and then you'll have your stuff, your items, each item on one line, just so it breaks down. You can see the information a little easier that way, instead of them being just, separated by commas and more spaces, and just kind of runs along. You can run it that way if you want to, but it will be hard to read. One thing you'll learn about coding, and if you look at PEP 8, the style guide with Python, you typically, you want to break your stuff into lines. It can only be so long. There's lots of different styling guidelines, which I talked about on day one, that you'll want to keep in mind. In this case, this makes it easy to see the object, right? And so it says we want to update the car object to include the new amount of miles in the odometer. So we want to update this to where it almost calculates things correctly versus us just assigning new values. Because we're calling the function on this, and then we want to use the information we get in our second parameter to update this object, and then return it, return the object with the correct things. So in this case, we kind of know what we want to return. We want to return people doesn't change. The miles is going to change because we're going to drive 1,500 miles. And then we want to calculate the number of spare tires used. So, gosh, how do we approach that? So let's see here. So how can we do this? Let me go ahead and clear my outputs that are gone. All right. Anybody have any ideas? It says update the car object to include a new amount of miles in the odometer. Okay. So it takes in the car object, and we have to do something with the miles. So let's see.
So we create a function for car object.
Yep. So we have we define the car trip. So we have the function in here, and we have the car object coming in, and then we have the miles driven. And so we don't want to just we want to make sure this and this is reflected appropriately based on the guidelines we got here with this. So how many miles we drove will determine how many spare tires we've used, what's on our odometer, stuff like that, right?
So
This
a loop
1,500
where,
is starting. Go ahead.
yeah. Oh no. Can we create a loop? Or I guess arithmetic solution with this? Like a math equation?
Yeah, I don't think we need a loop over anything for this one. I think we need some sort of equation though, because we need to update the miles, right?
What if we compare? So 1,500 is the starting and 7,000 is the ending mileage, or is 1,500 the number of miles driven?
So 1,500 is the miles that's already on the odometer, and then we're driving 5,500 miles.
So what if we? I mean, a math equation, but doing a comparison of. No, that's too complicated. I mean, it's really simple. You just have to figure out the difference in mileage and then divide that by the mileage for changing the tire, which is 1,000. I mean, the answer is going to be 5.5, and then we're going to round that to an even number, round down to 5 tires. But
Yep.
how do we plug that in? I was thinking of like a greater than equation, but that's not necessary either.
So we
It's
could do like car object, right? So car object at the key of, let's start with miles, right? So we can do miles. We could say, we could either say like equals, well, no, we don't want to do that. We just want to, we almost want to increment it, right? So what if we did, because right now, if I called car object miles, I'll get back 1500, right?
how do you subtract? Because
So
we
you
know the
added
start.
1,000 miles to each.
If I were to access car object at the key of miles, if I were to just put that into like the code block and run it, I would get back this number. And this would be an integer, right? So
Yeah, help me understand this code here, because we've got the top part, right? 1500, that's the keys. And then down at the bottom, that's the end, right? It's already spit out 5 used tires, or 5 tires used.
mhm.
So we're trying to solve it ahead of this dictionary here, yeah?
Correct. So yeah, so you don't, basically you don't want to use like hard-coded values here, right? Because in this case, if you take a look here, this is kind of what I'm thinking, right? So we have our car object and we're accessing it to, we're accessing it. If I were to just access it to see it, I would just put this in right here. But I want to use the value and do something with the value. So what if I just incremented it with miles driven? Because miles driven will be what? What is this when this function runs?
That's what I was confused on. How does it know what the miles driven is? Is that the 5500 down there after the on
Yes,
line 17?
because I'm calling it, right? So remember, we're writing a function to take in anything, right? Any car object or any miles driven, right? But when we design the function, when we call it, we want to make sure when we do call it, our data will fit into these parameters, right? So in this case, we're calling car trip right here. That's the function. Remember, I had like function defined here, then function called here, right? So we're calling the function, and then we're giving it 2 parameters. We're giving it this parameter right here, which is the object or car object, and then miles driven. So when I call this function, miles driven becomes 5500. Car object becomes this object. And
I
so
was
now,
thoroughly confused because I didn't see I didn't see the comma 5500, and now I see that's the second part of. Okay,
right.
now I understand the correlation between the two. So we need to
Yeah.
call out the miles driven minus the miles,
Yeah.
or not even that complicated. You just need to call out the miles driven and then divide that by. We need to set a parameter for the number of occurrences of 1000 increment.
Yeah. And we don't have to, we can define something if we want to, right? So like, let's say we can say, because we don't have that, so we can say, car or tire change interval, right? So equals 1000. We could do that and say, okay, now we know every time we hit 1000, we can trigger our tire change interval or something, right? So we have that, and then we can say, okay, well, then let's see, car object. So car object at spare tire used. So is it spare tires used? Yeah. And that could be equals. And so we just need to use this and this to come up with a result.
Yeah, it'd be mile. Well, I don't know if this is doable, but miles driven divided by tire change interval.
So miles driven divided by tire change interval.
Yeah, I mean that gets you the math, but does it?
I don't know. Let's see. So, and I run this. Basically, what I'm going to get is a true or false, right? So I should get true if the return of this function equals this, right? So I'm going to return the car object because I'm changing some things about the car object, and then I want to return it. So if the return of this function, which would be this entire thing, right? So whatever this function returns equals this, then I should get a true. I'm getting a false. Okay. So something's not right.
Is it because of the difference of 500 miles? Oh no, it's 4,000 miles. No, it's 5,500. So it's
5,500.
5.5. It's a floating number.
We don't want to float.
So
Maybe changing the
do you put an
value.
integer in front of tire change interval? Or no, in front of. We want it to round down, right? To an even number.
Mm-hmm. Do you remember any methods that we used in the first lesson?
That's what I'm trying to remember. I can kind of visualize the concept, but not the word for it.
Everyone's using math floor. What about that?
Floor. Yeah, that's it, right?
Mm-hmm. So the floor division, remember the double slash is floor division, and then you had the modulo for like to get just the remainder. So floor division is just a double slash, and then you'll get whatever how many times this can be evenly divided into miles driven. So it's 5 times. So you come back with the integer of 5. And so if you look, that's true. It looks like the result of my function is true because the calling of this function comes back with this same exact thing. So evaluate those two and ended up being true. And of course, I could always just print my object too right here just to see. So I never printed it out, so I never saw it, but I could now. So I can do print car object, right, and say, so I can see it, I can put something unique in front of it. So I can say this is the object. And put a comma there so I can see it. And I can run it. And now I can say this is the object. People, Spider-Man, Batman, miles, 7,000. Spare tires used 5. And then you can see what happens if you took away that floor division. I came back with 5.5, which didn't match that. So that's why I came back as false. So I had to use floor division. So that's what that is.
So was the object of this challenge to make it equal true, or was it to? It wasn't to calculate the number of tires used because it was already given.
The whole objective of this exercise is to get you used to seeing how you can use keys to access values and do things with those values. So we accessed the value here, but we knew that it was an integer right here, right?
Mm-hmm.
And so we say, okay, well then I can just use increment. I can just increment that, for miles driven because that's also an integer. So I can use an integer to increment an integer. So that's kind of something new. We kind of already knew the data type here of car object at miles, which is an integer. But the data type of people, which we didn't even touch people because, thank goodness we didn't lose somebody on the trip. And so we didn't even mess with the people key at all in this example. But then we did mess with the spare tires used, and that was also an integer. And we had to increment it based on some math. So
Help me out with plus equal. I'm not familiar with that one. Somehow it's escaping my mind. Why not greater than or equal to?
That is the same thing as saying this. Car object miles plus. So what I did, the plus equal, is the same thing as saying this, which is I want to assign car object the key of miles. I want to make it whatever it is before plus this value. Like it's the same exact process. So it's just a shorthand way of incrementing things. So instead of writing that all out like that, it's just that. So you're saying, hey, I want to take whatever this value is and then add whatever this value is to it.
Can you
Conversely,
elaborate
you
on
can
that
use
a little
minus
bit more?
equals subtract. So what's up?
Can you elaborate on that a little bit more? Because I'm not understanding that line that you just explained. I know what the plus equals
Sure.
does, but
So
can
he'll
you
say
put the
my
with it?
integer, right?
Can
So
you put
my
the
integer
numbers with it?
equals 5. Okay. Now if I want to increment my integer, I can do it several ways. I can say my integer equals my integer plus 1, and then I can print it. Okay. So I can do that, right? So it starts off as 5, and then I'm redefining it as to what it was before plus 1. So what will come out in this print statement then?
6.
Yes. I could also just do this. And I also get 6. That's what that is.
I'm just trying to
So
understand.
is it
Trying to
another
make
way of saying equals plus 1 or equals plus?
It's just a shorthand way of saying, hey, I want to add 1 to whatever this value is before. It's just a shorthand way of doing it.
Gotcha. So it's equal to 5 plus 1.
Yep.
Can you plug in the miles right there so I can see what it's doing with?
Oh, I see what you're
That's the
saying.
part
So
that
you want to do
confuses me.
this, right? So do it this way, right? So go over here. Let's do this. Let's see. Oh, goodness. Whatever, that'll work. Okay. And then let's just do 1,000 here, right? So okay. So here I'm going to define a new car object, and it's going to be the same thing as in the problem, but it's kind of reset. So it's now I have a car object, and I can go ahead and print it. Let's go ahead and print it too, so we can see it. Print car object. Let's run that. Okay, so there it is. There's my car object, right? And then here I'm saying, hey, car object at the key of miles, I want to make it 1,000 miles more than it is. If I run that, now it's 2,500. But I could also do this equals. I have to just reference the car object again. Plus 1,000. So I'm going to run this again to reset it back to 1,500. If I run this again, now it's 2,500. If I ran this again, now it's 3,500. Because I'm just referencing it what it is. Every time I run this in memory, it's going to increment car object at the key of miles by 1,000 every time I run this.
So you could use this with a loop if you said, okay, we took 5 trips, loop it 5 times. That's 5,000 miles. Could you scroll back up to the original way you had it written? Okay, plus miles driven, right? So we know that it's 5,500 miles driven because that's the second
parameter.
Parameter you know, at the top there. So all you did was say, instead of plus 1,000, like you just showed us down below, you're saying it's the number of miles we started with, which is down there in the key at 1,500, plus the number of miles driven, which is the second parameter, which is 5,500. So it's just a shorthand way of writing. It's the number of miles driven plus 5,500.
Yeah, this is a very programmatic way of writing it, right? So this is very flexible to change, right? So I don't have to change anything in the function really to make other calculations. I could have a completely different object and it'll still work as I designed here, right? So let's say, for example, now we know the trip that the road is smooth, and then we only have to change the tire every 3,000 miles. I just need to change it right there. And because I'm using variables, this becomes 3,000, right? Or if I have another example, let's say I want to travel, let's say I want to travel 7,000 miles, right? So when I run this, and let's just go ahead and actually it'll print out anyway. If I run
You're
this
gonna need to
now,
change your miles at the bottom there, aren't you, to 8,500? Or does that matter? The line 28.
it does it. It does the calculation right here. So see
Okay, so
how
line
after
28, line 28 is a key. That's why that doesn't need.
right. So line 28, so remember this right here is not really, this is from the exercise. So when we go back to the exercise, right? When we run this, we're going to get a true or a false. That's all we're going to get back, because this is what this script is doing is it's comparing the result of the function to a intended result to give me a true or false, right?
That's line 19 with the equals. Gotcha.
Yep, it's comparing the two, but now we're kind of going away from doing that comparison. We're just taking a look at, what happens if I change tire change interval to 3,000. This is very programmatic way of thinking and writing, because now instead of changing hard-coded values in my function, I just have references to whatever the input data is. And then, there may be some numbers used for some, formulas or something, but this right here, this is a very flexible way of seeing how, if you look here now, I only changed my tire twice, but I drove 7,000 miles because I changed my tire change interval to 3,000. So back to a rocky road. If it's a rocky road, then tire change interval is 1,000. If I run that, now I changed my tire 7 times.
Need to buy better tires.
Yeah.
How does
So
it know to apply the 7,000 to increase miles?
what's that?
The 7,000 you have after bracket comma 7,000. How does it know to dedicate that to the miles 1,500 plus 7,000?
The miles driven, because when I'm calling my function, this is what I'm using to call the function, right? When I'm calling this function, these two things become the parameters. This object becomes car object, and then this becomes miles driven. So my function inside of here can respond to whatever input data comes in. That's the beauty of functions. This is what I talked about on lesson 2, is when we're looking at functions, functions are become little apps or programs that we're writing. They're reusable. I can use this for any purpose that I need, and I don't have to think about what's happening inside the function. Once it's done, I just give it this data and it gives me out a result. All I care about is I know that this will calculate stuff for a car trip for me, right? I have this function called car trip. I just need to give it the people, the miles, and then it will tell me how many spare tires I use based on how far I'm traveling, right? In this case, there's some changes I have to do inside the function because I'm changing something like my tire change interval, right? But this case in the description here, it says the road's very rocky, so you need to use an additional spare tire every 1,000 miles, right? I could make it a third parameter, and I could give, rocky or smooth, and then based on whatever parameter comes in, it can change this tire change interval to that. So I could do that, right? So I could say, okay, well, and let's move this down here. Let's get away from this evaluation piece and just move it to here so we can kind of see it a little easier, right? So in this case, I could say road condition, right? And then I can have some logic in here. So I can say if road condition equals rocky, LF road condition equals wet. I'm just going to come up with some terms here. Tire change interval equals, let's do every 5,000 miles. I don't know, do tires wear down faster in wet roads or dry roads? I don't know. Else is just smooth, and we can say else tire change interval equals 3,000. Okay. Terrible tires, right? Change your tires every 3,000 miles. You are buying some pretty crappy tires. So
stop putting spare tires on your car.
Yeah.
Donuts.
So in this case, now we have our road condition. So we need to, let's see, this is our car object. Or this is our we just call it vehicle, right? So vehicle. And then, or let's say vehicle, let's get vehicle. And then, so we want to actually call this function now. So we have this function. And we want to say, okay, well, let's do car trip, which let's print it. Print car trip. And we want vehicle. And we want to drive 10,000 miles. And it's going to be just smooth. Okay. And so now we have our vehicle. So this is our object that goes in, right? Or, we can call it car object. We can call it car information, whatever we want to call it. We're going to call it vehicle, right? So vehicle, and we're driving. So that's our first parameter, which is vehicle. That gets put into car object when the function is running. So when the function is running, car object is vehicle, which is this. Miles driven is that. And then the road condition smooth. And so now you can see, okay, well, I'm going to be, when I run this function, smooth gets put in here. And that's the first, it hits this if, and else statement. And it evaluates what the road condition is. In this case, if road condition is rocky, our tire change interval is now that. It becomes a dynamic tire change interval based on this logic tree. And then, so in this case, we're smooth. Well, smooth, rocky, or wet? Nope. Well, now we know our tire change interval is going to be 3,000. And then it's going to do the same thing it did before. And so if I run this, okay, it comes back. I can get rid of this actually now because I'm printing out the result of the function. I took the function out. So I run that. Now the miles is 11,500 because I ran 10,000 miles, and I used 3 spare tires because I ran it every 3,000 miles. I had to run a tire. But what if I change this to Rocky and I run it? Now I use 10 spare tires. And then wet. I run that. Now I only use 2 spare tires because I change a tire every 5,000 miles. So that's how you can use programmatic writing to change an output of a function. And all I have to do is just change my input parameters to get that. I can change how many miles I drive, right? Just right there. It all changes. It's all flexible inside the function because it's all driven by variables that I've assigned, either through parameters or assigned inside the function to return. Does that make sense to everybody? To see that process and how I'm changing things in a dictionary and how a function's working and how we're changing things and seeing the programmatic writing.
The if else seems much shorter than the first time you did it. It's just like, could there have been a shorter way to do it than kind of writing each line like that?
There is a shorter way. I like to write it this way for you guys now so you can kind of see everything. Like it just makes things easier, assigning variables and everything else. I mean, again, we had a
Yeah,
couple conditions here, but yeah.
Yeah, like if we were doing simple math, like for the first example, could there have been a shorter way of writing it versus like kind of
Are you talking about here?
yes.
Okay. What do you mean a shorter way of writing it?
I guess with like all the variables, like all the lines, could we have condensed it into like 1 or 2 lines? Or
I don't think so. I think this is probably the best way. I mean, we could have gotten rid of this because I was printing that, we don't need that. But like this is pretty short. And even then, like no, we needed to define tire change interval, or just hard coded 1,000 in here, which wouldn't be as programmatic. I like this better because you're making a variable now that you can change. If you use this more often, you would have to, change it there too. But if you just make a variable, it's very common practice to make variables like that you're going to use later instead of using hard coded values for that. But no, the math for this is pretty much as short as it's going to get, right? So I'm referencing the key, getting the value, and then I'm doing that math, the floor division here to get it. This right here is about the shortest result you're going to get. I mean, for the most part, it'd be pretty standard for a function to be like that for such a simple calculation.
okay. Could you
Yeah.
recycle for line 2? I think it was at line 2, the miles. Why were you restating it again?
What's that?
Line 11.
Uh-huh.
So we got the miles. I'm guessing that's the 5,500 that we had originally.
1,500. So right here, this is
Oh, never mind. I don't
this.
know. 5,500,
Yeah,
whatever.
this right here is that. Because it's
Oh.
being fed in as car object, so it then becomes car object miles. That's what that is. Yep.
Oh, okay, and then the miles driven was 5,500. Okay.
Yeah. And so then, yeah, I think here this was supposed to be 5,500, right? We had just changed it when I was messing with stuff, right? So that's supposed to be 5,500, and then that is miles driven, so that gets this. And so when you put them together, you get the 7,000. Yeah. So if I ran that, ends up being true again because I had edited that when I was illustrating a point. So, but in this example here, we then added a little more complexity with how the road condition, can change how often we have to change a tire by just throwing this if like else tree in here. So
Okay.
Yeah. So that we're about, yeah, it's 8:55. So that was a pretty good explanation of, and a little more expansion on how to, when we're inside of a function, how we can do things, but also kind of really, showing how we can access the keys and values in a dictionary. That's the whole point of this exercise was kind of help you see how you can not only assign a value, but you could also like change a value and use it in calculations. And it becomes really powerful. And we'll see that when we get to the mini projects. You're gonna come across, if you keep going with the development stuff, you'll come across dictionaries that are thousands of lines long with all sorts of keys and values and nested dictionaries. And we're going to show those too in lesson 6. So on Thursday, we're going to go over some advanced data collections, and you'll see some of those multi-structured data formats that you'll have to know how to access. And so it's not too scary, I promise. But hopefully this lesson, this exercise kind of helps you see the dictionaries and how important they are and how powerful they are when doing a calculation, even though it's still a silly example. But yeah, we're basically at the end. So any other questions on what we learned today? No questions, huh? Anybody having other issues? You're welcome, Ruthie. Any other issues getting code to run?
I'm still having issues being able to get GitHub to work correctly so that I can.
GitHub code spaces?
Yes, sir.
Okay. So let me I'll pull it up again. I think we have a few more minutes before the end, so we can go over that. I can stop the recording now. I'll go ahead and stop the recording now.